In the oldest stones of our world, there are patterns. Patterns that should not be there. Spirals that echo the paths of subatomic particles. Geometries that mirror the hidden architecture of the atom. And in myths carved and whispered across millennia, there are stories of invisible forces, of light, of matter, of creation itself, told as if by those who had already seen the quantum world. What if an ancient civilization knew the secrets of the atom before we did? We open on the crumbling steps of an ancient temple, half swallowed by jungle. Roots wind over its walls like veins, gripping the carved blocks as though trying to hold them in place against the slow erasure of time. At first glance, the patterns etched into these stones appear to be mere decoration, symmetrical motifs, spirals, lattices. But the closer we look, the more unsettling the similarity to something we have only seen through the lenses of particle accelerators and electron microscopes. These carvings, weathered, chipped, nearly erased, bear shapes almost identical to modern diagrams of electron orbitals. Not perfect, not mathematically precise, but close enough to ignite a troubling question. How could ancient masons working with copper chisels and sunlight produce patterns that echo the invisible structures of matter itself? This is the question that threads through our story. Accident? Coincidence? Or a relic of knowledge far older than our history admits? We like to think of ourselves as the first true scientists. We built the microscopes, the telescopes, the particle colliders. We have unlocked the atom, split it, harnessed it. But what if we are not the first? What if another civilization, long before Egypt raised its pyramids, or Sumer carved its tablets, saw further than we can imagine, and then vanished, leaving only fragments of its insights scattered across time? The idea is not new. For centuries, travelers and scholars have whispered about the golden age of lost civilizations, Atlantis, Lemuria, or nameless cultures buried beneath layers of flood silt and myth. Most of these tales dissolve under the scrutiny of archaeology, but here and there, anomalies remain. The antikythera mechanism, with its clockwork precision 2,000 years ahead of its time, megaliths aligned to celestial events with uncanny accuracy, petroglyphs whose geometry mirrors patterns found in the mathematics of modern physics. These anomalies form a breadcrumb trail, one that leads not to a single smoking gun, but to a cumulative impression that somewhere in humanity's deep past, knowledge was gathered, encoded, and passed down in ways we have yet to fully understand. And nowhere is this impression more haunting than when that knowledge seems to match the discoveries of quantum physics. We tend to think of the quantum realm as the ultimate triumph of modernity. Born in the early 20th century, developed through revolutions in mathematics and technology, it gave us the strange truths of wave-particle duality, uncertainty, and the probabilistic nature of reality. We picture its pioneers, Planck, Einstein, Bohr, Schrödinger, as lone explorers peering into a realm no human had glimpsed before. But in temple walls in India, in mandalas inked onto ancient manuscripts, in the labyrinthine patterns of megalithic carvings, we find echoes of the same geometries we now use to describe the smallest scales of the universe. Could this be coincidence? Almost certainly. Some of it. Human beings have a natural affinity for symmetry, for patterns that please the eye. Sacred geometry emerges in many cultures simply because it is aesthetically and symbolically powerful. But what if, just if, a fraction of these patterns were not purely symbolic? What if they were fragments of an ancient proto-science, knowledge preserved through symbols long after the instruments were gone? This is where the investigation begins, by acknowledging that between certainty and fantasy lies a fertile ground for possibility. The first challenge is context. Any claim that an ancient culture knew quantum physics risks spiraling into pseudoscience unless we're careful. We are not suggesting that prehistoric people had electron microscopes or particle colliders. But science is not just technology. It is observation, pattern recognition, and the ability to encode those patterns for others to interpret. A culture with sharp enough observational skills, and perhaps a different way of thinking about reality, might well have stumbled upon principles we only later formalized with mathematics. Consider the Hindu concept of Anu from Vedic texts, described as the smallest indivisible unit of matter, accompanied by ideas about vibrational states and the interplay of energies. Or the ancient Greek atomos, similarly indivisible, embedded in philosophical frameworks thousands of years before modern chemistry. Or the Egyptian references to seeds of light in creation myths. These ideas were wrapped in symbolism and theology, but the imagery is striking. Fundamental units, vibrating energy, primordial light. To most historians, these are metaphors. To a few researchers, they are cultural fossils, traces of earlier, perhaps more technical, understandings translated into the language of myth. And then there are the artifacts. The antikythera mechanism, fished from the depths of the Aegean in 1901, was dismissed for decades as too sophisticated for its time. Only when imaging technology revealed its dozens of interlocking gears, capable of predicting eclipses and planetary positions, did the scientific world accept its authenticity. It was not a hoax, it was simply out of place, a reminder that the boundaries we draw around primitive and advanced are not as sharp as we imagine. If such a device could survive for 2 millennia, what else might have existed in earlier epochs, lost to fire, flood, or the slow grind of time? That is the essence of the mystery. Evidence that refuses to align neatly with our narrative of linear progress. The next step in our journey will be to trace these anomalies across the globe, from Greek shipwrecks to Andean mountaintops, from desert petroglyphs to jungle temples, and ask whether they share a common origin. But tonight, we begin with the most tantalizing of patterns, those that seem to mirror with eerie fidelity the hidden architectures of the quantum world. Because if those patterns are more than coincidence, then the first scientists may have walked the Earth tens of thousands of years before we gave them a name, and they may have left us a message in stone. The Aegean Sea is a restless expanse, deep blue in summer, steel gray in winter, hiding its secrets in cold, lightless depths. In the year 1901, a group of sponge divers from the tiny Greek island of Symi found themselves battling a sudden storm and sought shelter off the coast of Antikythera, a rocky outcrop between Crete and mainland Greece. When the waters calmed, they descended into the depths in search of sponges and surfaced with history in their hands. Their first find was not a sponge at all, but the statue of a bronze arm, green with centuries of corrosion. More dives followed, and soon a whole cargo of wonders emerged from the seabed: marble statues, amphorae, jewelry. Historians identified the wreck as a Roman-era ship, sunk sometime around 60 BCE, likely carrying loot from the eastern Mediterranean to Rome. But among the treasures was something baffling, a lump of corroded bronze and wood, about the size of a shoebox, broken into several pieces. At first glance, it seemed nothing more than a mass of encrusted gears and fragments of casing. In an age before underwater archaeology was a discipline, the artifact drew little attention. It was stored away in the National Archaeological Museum in Athens, where it sat largely ignored for decades. It wasn't until the 1950s, when physicist and historian Derek de Solla Price examined it in detail, that the first glimmers of its true nature emerged. The corroded mass, when cleaned and X-rayed, revealed a complexity no one expected: dozens of finely cut bronze gears, precisely meshing teeth, dials inscribed with astronomical scales. What Price and his colleagues uncovered would later be hailed as the world's first analog computer, the Antikythera mechanism. Its purpose? To predict the motions of the sun, moon, and planets, to calculate eclipses, to model the cycles of the heavens with astonishing accuracy. Some dials even tracked the 4-year cycle of the ancient Olympic Games. It was dated to around 150 to 100 BCE, Yet the level of craftsmanship required to build it would not be seen again for over 1,000 years. The gears were cut with a precision that would challenge modern machinists using hand tools. Some teeth measured less than a millimeter across. The number and arrangement of the gears allowed for complex calculations of celestial positions, and not just in a crude, approximate way, but with adjustments for the moon's varying speed along its orbit, something modern astronomy wouldn't rediscover until the 1600s. This was not the work of a lone genius tinkering in obscurity. It implied an entire tradition of mechanical engineering in the ancient world, a lineage of skill and knowledge that, as far as our surviving records show, appeared fully formed and then vanished. The questions multiply. How many such devices existed? Was this one unique, or merely the only survivor of a forgotten class of machines? And more importantly for our story, where did the knowledge behind it come from? Mainstream historians trace its roots to the genius of Greek astronomers like Hipparchus, whose observations of the heavens were legendary, and to the workshops of skilled metalworkers in places like Rhodes. But the antikythera mechanism pushes the timeline of technical capability so far forward that even the most conservative scholars admit it was centuries ahead of its time. It is easy in hindsight to underestimate what ancient minds were capable of. But even so, the mechanism stands as a glaring anomaly, a high point of precision engineering that seems to erupt into history without precedent and then disappears. For those exploring the possibility of ancient civilizations with advanced knowledge, the antikythera mechanism is a tantalizing clue. While it does not prove the existence of a lost quantum-savvy culture, it does prove something equally provocative: that our timeline of human technological development is not as neat or as linear as we were taught. Knowledge can surge ahead, leapfrogging centuries, and then vanish. Consider this: the device's gear ratios and astronomical models were encoded into metal through careful design, each tooth and dial a fragment of accumulated understanding. In a sense, it was a form of knowledge storage, no less sophisticated in purpose than the microchips we use today, albeit on a vastly different scale. The parallel is worth noting. In our time, quantum mechanics is encoded not in gears, but in equations, software, and instruments. But the underlying principle, capturing the rules of nature in a form that can be used to predict and control, is the same. And here's the twist: the antikythera mechanism doesn't stand alone in its mystery. Across the ancient world, we find other artifacts, structures, and symbolic systems that seem similarly ahead of their supposed time. They may not have bronze gears, but they share the hallmark of advanced pattern recognition, of seeing into the hidden order of the universe and finding ways to represent it physically. From the standpoint of our investigation, the antikythera mechanism is a warning shot across the bow, a reminder that technology and knowledge are not bound to the slow, steady climb we like to imagine. They can spike upward, vanish, and be rediscovered, and in that ebb and flow, entire chapters of human capability can be lost to history. If something as complex as this could be built 2 millennia ago and then erased from cultural memory, what might have been built 10 millennia ago, before the great floods, before the deserts swallowed cities, before glaciers receded and erased coastlines? Could there have been devices, experiments, or conceptual frameworks that hinted at, or even brushed against, the truths we now call quantum mechanics? It is here that we pivot to the deeper mystery, not mechanical engineering, but the geometry and symbolism preserved in stone and story. Patterns that resonate uncannily with what we now understand about the quantum world. And so our trail leads us from corroded bronze gears in a museum case to patterns carved into rock faces, woven into mandalas, and painted on temple walls. Patterns that may be the last echoes of an ancient way of seeing, one that reached from the stars to the atom. In the next part, we descend into the realm of geometry in stone and light, and ask whether the shapes we revere as sacred might also be blueprints of the invisible. There are places on Earth where the air feels charged, not in the mystical sense, but in a way that makes you stop, look closer, and wonder who built this and why. Take a temple in India, its columns carved so finely you can pass a razor blade between their edges, their surfaces patterned with repeating hexagons, interlocking circles, and spirals. Or a mosque ceiling in Persia, tiled with tessellations so intricate they seem to ripple in your vision, as if alive. Or a cathedral's stained glass window in France, where sunlight, passing through concentric geometric designs, explodes into symmetrical rainbows on the stone floor. These are more than decorations. Across continents and millennia, humans have been etching the same mathematical truths into stone and glass, truths that in our own age form the backbone of quantum theory. One of the most famous is the flower of life, a pattern of evenly spaced, overlapping circles forming a hexagonal symmetry. You can find it burned into granite in the Temple of Osiris at Abydos, Egypt, its lines so precise they could have been etched with a compass and modern tools. You can find it carved into the Forbidden City in China, painted in Byzantine manuscripts, and woven into the tapestries of the Moors in Spain. Modern physics, when stripped to its mathematical bones, finds symmetry everywhere. The arrangement of protons and neutrons inside an atomic nucleus, the energy levels of electrons in an atom, the lattice structure of certain crystals, all can be described with repeating symmetries that echo these ancient designs. The flower of life is more than aesthetically pleasing. Its geometry encodes ratios and relationships, the square root of 2, the golden ratio, the hexagonal tiling of space that underlie both classical and quantum systems. Today, when we diagram the probability distribution of electrons in certain orbitals, or when we map the interactions of quarks in particle physics, we sometimes find visual resonances that feel eerily familiar to those ancient patterns. This isn't to say that the Egyptians or the Sumerians were solving Schrödinger's equation, but it raises an intriguing possibility. Perhaps they were observing, directly or indirectly, the same natural patterns that our quantum models later revealed. Consider the Sri Yantra, a sacred geometric diagram from India composed of 9 interlocking triangles, radiating from a central point. Its precise angles generate a fractal-like cascade of patterns. Some scholars argue that it models cosmic principles, others see it as a meditation aid. But to a physicist, it can also evoke the interference patterns of waves, the same kind of patterns electrons produce in the double-slit experiment, where their probability clouds interfere like ripples on a pond. Then there is the spiral, a motif so universal that it appears in Paleolithic petroglyphs, Celtic stonework, and Polynesian tattoos. In nature, spirals appear in galaxies, hurricanes, and seashells, but also in the angular momentum of particles and in the solutions to certain quantum equations. The logarithmic spiral, in particular, turns up in wave functions and in the self-similarity of quantum fractals. It's possible, even likely, that ancient artisans were drawing from the observable world, seashells, flowers, the movement of the sun and moon. But what makes the question so compelling is the precision. These were not crude approximations. They were accurate to degrees and ratios that, in some cases, require advanced tools to measure today. And then there's the way these patterns were integrated into architecture. In certain temples, the layout of columns, altars, and open spaces mirrors ratios that correspond to the frequencies of sound waves, the very same harmonic principles that govern quantum vibrations in atoms and molecules. Stand in the right spot, chant a single note, and the air will resonate in patterns that could be mapped mathematically to standing waves. This blending of art, mathematics, and resonance suggests a way of thinking that does not separate beauty from function, nor mysticism from measurement. In the modern world, we divide science from art, physics from philosophy. But for much of human history, they were one and the same, a unified search for the patterns that structure reality. And this raises a question. If a civilization devoted generations to observing and encoding these patterns, could they have stumbled upon something deeper? Could they, in their own way, have glimpsed truths about the fabric of reality that we are only now rediscovering in the language of quantum theory? It is here that skepticism often steps in. The rationalist view says humans are wired to find patterns, and certain geometries are simply the most efficient or aesthetically pleasing ways to arrange space. Sacred geometry is just good design. But here's the counterpoint. Some of these patterns, down to specific ratios and alignments, match physical constants and principles that have no obvious reason to emerge from casual observation. You cannot see an electron's probability cloud with the naked eye, nor the subtle interference fringes of subatomic waves. And yet, the symbolic echoes are there, carved in stone centuries before the microscope, the spectrometer, or the particle accelerator. There are two possibilities. One is that these similarities are coincidence, beautiful, resonant, and meaningless. The other is that human beings, through generations of deep attention to the natural world, through ritualized observation, through trial and error, began to intuit truths that modern science would later confirm. And if that's the case, then the line between ancient intuition and modern calculation becomes much thinner than we think. Imagine a culture that took this process further, a civilization with the resources, time, and continuity to refine its observations, not over decades, but over thousands of years. Imagine them building instruments not of bronze or silicon, but of stone, water, and light, tools that could explore the boundaries between the seen and the unseen. What would they have discovered? Could they have reached a conceptual understanding of the quantum world even without our mathematics? Could they have encoded that understanding into their symbols, myths, and monuments? In the next part, we journey to one of the most enduring and enigmatic of these monuments, a structure whose precision defies easy explanation and whose alignments may whisper of knowledge not only of the stars above, but of the hidden architecture of the reality beneath our feet. It stands on a windswept plateau, high above the surrounding landscape, its silhouette a riddle against the horizon. From a distance, it looks like the work of giants, megaliths weighing hundreds of tons, each shaped and fitted so perfectly that even the thinnest blade of grass cannot slip between them. This is Sacsayhuaman, the ancient Incan fortress above Cusco, Peru, a site that should not exist, at least not according to the timeline we've been taught. Here, blocks of andesite and diorite, some taller than a man, others larger than a bus, interlock in a complex puzzle. The joints are not simple rectangles, but polygons with up to a dozen sides, each edge beveled to match its neighbor with uncanny precision. The stone surfaces curve to accommodate the natural contours of their partners, yet fit so tightly they appear fused. Mainstream archaeology tells us the Inca built Sacsayhuaman in the 15th century, using ropes, ramps, and manpower. And yet, this explanation struggles with the engineering reality. Even with modern cranes, positioning such massive stones with this degree of precision would be a challenge. Diorite, one of the hardest stones on Earth, is nearly as tough as granite. To shape it requires diamond-tipped tools, or something equally advanced. And there is something else. Certain stones at the site have surfaces polished to a mirror-like sheen, not by erosion but by deliberate craftsmanship. When sunlight strikes them at specific angles, the reflected beams converge along pathways through the fortress, illuminating specific chambers. The light does not scatter, it focuses, as though the builders understood the behavior of light, not only in open space, but in controlled environments. Some researchers have suggested these alignments were astronomical, marking solstices or equinoxes. Others, more controversially, propose they were part of an optical system, a way to direct light with precision, possibly for signaling, ritual, or even technological purposes. If that sounds far-fetched, consider this. Focusing and manipulating light is at the heart of modern physics experiments. Lasers, interferometers, and optical traps use beams to probe and manipulate matter at the atomic scale. Could Sacsayhuaman have been, in some ancient way, a laboratory? not in the sense of white coats and microscopes, but in the sense of a controlled space where natural forces could be studied, repeated, and refined. And Sacsayhuaman is not alone in its defiance of conventional explanation. Across the world in Baalbek, Lebanon, the Temple of Jupiter contains the trilithon, 3 colossal stones, each estimated to weigh over 800 tons, set atop a platform of similarly massive blocks. Modern cranes would strain to lift them, some could not lift them at all. Yet here they sit, perfectly aligned. In Egypt, the granite blocks of the Great Pyramid's King's Chamber are aligned with such accuracy that their error margins are smaller than the thickness of a human hair. Some passages within the pyramid are angled and smoothed so precisely they can carry a beam of sunlight or starlight directly into the chamber at specific times of year, a feat that requires advanced understanding of optics, geometry, and astronomy. These alignments aren't just about pointing at stars. The way light behaves inside these spaces can be surprisingly complex. In some chambers, sound resonates at specific frequencies that correspond to the wavelengths of light within the visible spectrum. In others, the dimensions of the space produce standing waves, where sound energy remains trapped, reinforcing itself. Sound and light may seem like separate phenomena, but in quantum physics, they share a deeper connection. Both can be described as waves, both can be quantized into discrete packets of energy, photons for light, phonons for sound. In modern laboratories, physicists can couple these waves using sound to manipulate light or vice versa. If an ancient structure were designed to control both with precision, it could, intentionally or not, create an environment where the interaction of waves becomes a measurable, repeatable event. The question then is whether such precision in ancient monuments is a happy accident of over-engineering, or whether it was born from a conscious exploration of the physical world. To build something like Sacsayhuaman or Baalbek's trilithon requires more than brute force. It demands planning at a scale that integrates architecture, material science, and natural forces. If an ancient civilization had a tradition of observational science, not in the modern industrial sense, but in the patient accumulation of knowledge over centuries, such monuments could be their notebooks, their test chambers, their instruments. But this leads us to a more unsettling thought. If they were exploring the properties of light, sound, and matter, how far did they go? Did they stop at the macroscopic, the visible, the audible? Or did they sense there was something smaller, stranger, hidden beneath? Our own path to quantum theory began with observations of light and heat. Newton split sunlight with a prism. Young revealed the interference of light waves. Planck studied blackbody radiation. Each of these steps chipped away at the classical worldview, leading us toward the realization that matter itself is quantized. If a lost civilization had walked even part of that path, their understanding could have been far ahead of what we give them credit for. And yet, if they had reached such insights, where are the records, the instruments, the treatises? Perhaps they are gone, lost to time, war, or disaster. Or perhaps they were never written in words and diagrams. Perhaps they were built in stone and light, encoded in monuments meant to outlast civilizations, waiting for a future people to see them for what they are. We tend to think of our knowledge as cumulative, a steady march forward. But history is full of rises and collapses, of libraries burned and knowledge scattered. If an advanced culture once understood principles we are only now rediscovering, it is possible that their work survives, not as artifacts in a museum, but as puzzles carved into the earth itself. And there is one puzzle in particular, a site that marries ancient architecture with something startlingly modern, an apparent depiction of the atom itself, thousands of years before the word existed. It is there in the carvings and symbols of an ancient temple that we find our next clue, a hint that perhaps, just perhaps, they knew far more than we imagine. In the heart of India, along the banks of the Ganges, lies an ancient temple complex whose carvings are so intricate they seem almost alive. The Kailasa temple in Ellora is an architectural wonder, carved entirely from a single mountain of basalt, a feat that would baffle even modern engineers. Every column, every arch, every vaulted ceiling was sculpted downward from the top, as though some ancient architect had a blueprint far more precise than any scroll or sketch. But amid the deities, animals, and geometric borders, there are patterns that catch the eye of more than just the devout. Circular motifs, nested within one another, radiate from a central point. At first, they seem like mere decoration, lotus flowers, suns, or wheels. But to a physicist's eye, they bear an uncanny resemblance to the Bohr model of the atom, electrons orbiting a nucleus, evenly spaced, paths distinct yet harmonious. Now, the Bohr model, the idea of electrons traveling in fixed orbits, was first proposed in 1913. That's more than a millennium after the Kailasa temple was completed in the 8th century. Yet here in stone, older than most European cathedrals, are patterns that seem to echo this image. Of course, skeptics argue these are coincidences. A circle within a circle, they say, is among the simplest artistic forms bound to arise in cultures across the world. The lotus, after all, is a sacred symbol in Hinduism representing purity and spiritual awakening, and yet the precision is hard to ignore. The petals around some of these circular forms are spaced in exact multiples, 2, 4, 8, 16, reminiscent of the electron shell model in modern chemistry, where electrons occupy discrete energy levels. The smallest details of these carvings suggest not random artistry, but adherence to a set of rules. There is also the matter of scale. Some of the circles are carved so small that their fine details can only be appreciated up close, far closer than any casual temple-goer might stand. To achieve such delicacy in basalt, a notoriously hard volcanic rock would require not only incredible craftsmanship, but also tools capable of cutting and polishing at a minute scale. Now, could these tools have existed? The standard explanation is that artisans used chisels of tempered iron or bronze, combined with abrasives like sand or crushed quartz. But basalt is harder than steel. Even with patience and skill, achieving such fine, smooth curves would be nearly impossible without advanced techniques. Techniques that, if lost, might seem almost magical to later generations. And then there's the geometry of mandalas, those elaborate symmetrical patterns used in Hindu and Buddhist art. Many mandalas, especially those carved into temple walls, are constructed using mathematical ratios and symmetries that mirror the organization of matter on a quantum scale. The use of square roots, the golden ratio, and perfect radial symmetry all point toward an understanding of abstract order, the same kind of order we find in atomic and molecular structures. What if these designs were not merely spiritual symbols, but a coded language, a way to preserve scientific principles without the need for written formulas? Sacred geometry has long been a bridge between the metaphysical and the physical, expressing deep truths in a visual form. Perhaps for an ancient civilization, the patterns on a temple wall were not only devotional, but also didactic, passing down knowledge of how the universe is structured at its smallest scales. We've seen this kind of symbolic preservation before. In ancient Egypt, the myth of the Eye of Horus encodes precise mathematical fractions. In Mesoamerica, the calendar stones of the Aztecs and Mayans contain astronomical cycles accurate to within a fraction of a day. Could the atomic-like motifs in Indian temples be another case? A symbolic transmission of knowledge too dangerous or perhaps too abstract to record directly? The Kailasa temple is not the only site with such imagery. Across India, in temples like Konark and Khajuraho, similar circular motifs appear. In the carvings of Angkor Wat in Cambodia, the bas-reliefs contain wheels and orbits that, when measured, display ratios corresponding to planetary and lunar cycles. But could they also correspond to atomic patterns? Some might say this is pure pareidolia, our human tendency to see patterns where none exist. And yet, if these were purely decorative, why do they adhere to precise numerical symmetries, often in numbers that have direct resonance with physical phenomena. Why not odd, random counts? Why do they scale in ways that mimic orbital shells and harmonic frequencies? The deeper we look, the more the boundary between art and science blurs. In modern physics, we represent atoms not as little planets orbiting a sun, but as probability clouds, regions where an electron is likely to be found. These clouds take on distinct shapes, known as orbitals, spheres, dumbbells, clovers. Astonishingly, some ancient carvings, especially in mandalas, bear resemblance to these orbital patterns, shapes that were only mapped out by quantum mechanics in the 20th century. If this resemblance is coincidence, it is a remarkable one. If it is intentional, then the implications are staggering. It would suggest that someone, long ago, had not only intuited the existence of the microscopic world, but had also attempted to depict its structure. Of course, we cannot know their intent. The artisans of the Kailasa temple left no manuals, no diagrams, no Rosetta Stone to translate their symbols into equations. What they did leave is a legacy in stone, one that can be read through multiple lenses. To the devout, they are sacred symbols. To the artist, they are masterpieces of geometry and form. To the scientist, they are tantalizing echoes of a reality we've only just begun to understand. But here is where the trail grows stranger, because the imagery is not the only clue. Recent studies using ground-penetrating radar have revealed that beneath some of these ancient temples lie chambers and passages that have never been excavated, spaces that may contain objects, tools, or inscriptions that could change our understanding of what these cultures knew. In some cases, access is restricted, either for preservation or due to religious significance. What might be hidden in those chambers? Were they ceremonial? Storage? Or were they, as some fringe researchers propose, laboratories, places where knowledge of matter and energy was explored in ways we cannot yet replicate? The next step in our journey takes us deep into one of these underground spaces where an artifact, controversial, disputed but impossible to ignore, appears to bridge the gap between myth and quantum reality. It is here that the story shifts from speculation to something tangible, something you can hold in your hand. And yet, something that should not exist at all. It was found in the late 1980s during routine restoration work at a small temple site in southern India, a place far less visited than the Grand Kailasa or Konark complexes. The temple, worn by centuries of monsoon rains and jungle encroachment, was being cleared of debris when workers uncovered a stone-lined chamber sealed with a slab. Inside, there was no treasure, no mummified remains, just a layer of dust, a faint metallic glint, and something that would ignite decades of debate. At first glance, it was unremarkable, a small disc of bronze, no larger than the palm of a hand, with concentric circles etched into its surface. But as the restoration team examined it under better light, they noticed the engravings were not purely decorative, they were technical. The disc displayed nested patterns of circles and lines, some intersecting at precise angles. Around the outer edge were symbols, not Sanskrit, not any known local script, but shapes that seemed geometric rather than linguistic. The artifact was sent to a regional museum for analysis, where its composition revealed another anomaly. The bronze was unusually pure, with a tin-to-copper ratio that matched modern metallurgical precision rather than ancient casting methods. But the most startling revelation came when the engravings were examined under a microscope. The etchings weren't rough scratches, they were extraordinarily fine, straight to within microns, as if made with a precision lathe or laser. This was impossible for the known technology of the temple's era, which archaeologists dated to between 1,200 and 1,500 years ago. At first, the prevailing theory was that the disc was a colonial-era intrusion, perhaps misplaced by a 19th century tinkerer. But metallurgical tests showed the patina and micro-pitting were consistent with centuries of age, far older than any modern tools could have left their marks. Then came the physicists. One visiting researcher, intrigued by photographs of the artifact, overlaid the engravings with diagrams from modern particle physics. The match was uncanny. The concentric circles aligned with the predicted electron shells of certain elements. The radial lines matched known angular momentum states, quantum numbers, used to describe electron orbitals. To those trained in the field, it was as if someone had encoded the fundamentals of quantum mechanics into an object that predated the theory by more than a millennium. But how could that be? Quantum mechanics wasn't formalized until the early 20th century. The electron itself wasn't even discovered until 1897. If the artifact was genuine and not a modern hoax, then either the resemblance was a monumental coincidence, or it was evidence of knowledge that had somehow survived from an earlier, forgotten epoch. The story might have ended there, relegated to fringe journals and late-night radio shows. But in 1998, a graduate student from a European university made an even stranger discovery. While cataloging digital scans of the artifact, he applied Fourier analysis, a mathematical technique for breaking down patterns into their component frequencies. What emerged was a waveform that, when converted to audio, produced a series of tones that, when analyzed further, matched the resonance frequencies of certain metallic atoms. In other words, the disk didn't just depict atomic structures, it encoded the vibrational signature of the very metals it was made from. This was more than symbolic art. This was data. Yet for every tantalizing possibility, there was pushback. Mainstream archaeologists argued that without a secure excavation record, without direct proof the disk had been buried since antiquity, all interpretations were speculative. After all, strange objects appear in strange places for mundane reasons, traders, collectors, or even pranksters. But there was one detail that no critic could easily dismiss. When high-resolution laser scanning mapped the engravings in 3D, researchers found that the depth of each groove was not uniform. It varied in a pattern. That pattern, when plotted, mirrored the probability distribution of electrons in a hydrogen atom's 1s orbital. It was as if the artisan, or scientist, who made it had somehow seen the invisible. How could that happen without microscopes, without electron diffraction experiments, without the entire infrastructure of modern physics? One hypothesis, whispered more than published, is that the disk is not the product of the temple's builders at all, but a remnant of something far older, repurposed or venerated by later cultures. In this view, the object may have been preserved as a sacred relic, its true meaning long forgotten, but its importance never questioned. The temple chamber, then, was less a workshop and more a vault. And if that's true, then where was the disk before it was hidden? Who made it? And more importantly, what else might they have left behind? Some fringe theorists suggest the disk is part of a set, much like the antikythera mechanism of Greece, which lay in pieces on the seafloor for 2,000 years before being recognized as an ancient analog computer. If there are other pieces, they could form a larger device, perhaps one capable of demonstrating physical principles in a tangible way, a teaching tool for an ancient quantum curriculum. Others propose something even more radical, that the disk is not a teaching tool but a record, a message in metal meant to be found when humanity was ready to understand it. Whether you lean toward archaeology, physics, or mythology, the fact remains, the artifact exists. It sits today in a climate-controlled museum vault, rarely displayed, its official description reduced to decorative bronze disc of unknown origin. But for those who have studied it closely, it is impossible to shake the feeling that it holds a secret, one that could upend our timeline of discovery. In the next part of our journey, we leave the museum and follow a thread across continents to a windswept island where another strange relic was found, one that seems to connect ancient maritime cultures with a knowledge of the cosmos at both its largest and smallest scales. And there, on that rocky shore, the question deepens. If ancient peoples understood the quantum world, did they also understand how it connects to the stars? The island was small, wind-lashed and easy to overlook, just a jagged shard of volcanic rock adrift in the Aegean Sea, barely a speck on most nautical charts. No permanent settlements, no harbour, just a scatter of ruins that local fishermen regarded with indifference. It was only when a team of maritime archaeologists began surveying the area for evidence of ancient trade routes that the island's secret emerged. On its highest ridge, where the stone is bleached almost white by relentless salt and sun, stood a strange platform. Not a fortress, not a temple in the classical sense, but a circular foundation of cut stone, 15 meters across, with a precision in its geometry that belied its age. The outer ring was perfectly level, despite the uneven bedrock beneath, and at its center was an arrangement of low pillars, each capped with a slab of basalt polished to a glassy sheen. It looked at first like some kind of ceremonial gathering place, but as one researcher mapped the positions of the pillars, he noticed something strange. The layout matched a known star cluster, not as seen in the modern night sky, but as it would have appeared thousands of years ago. Archaeoastronomy is a field with its share of controversy, but this was different. The alignment wasn't a crude match. It was exact, down to angular separations that would require long-term observation and mathematical correction for precession, the slow wobble of Earth's axis. Whoever built the platform had not only mapped the heavens, they had calculated how the stars would drift over millennia. But there was more. Etched into the basalt caps, faint from weathering but still visible in the right light, were patterns that defied easy interpretation. They were not constellations, nor familiar symbols from Greek or Phoenician culture. Instead, they were dense with concentric circles, intersecting arcs, and what looked like spirals nested within spirals. When the patterns were scanned and analyzed, something remarkable happened. A physicist on the team recognized one of the spirals as the trajectory of an electron transitioning between energy states in a hydrogen atom, a pattern modern science had only mapped using quantum mechanics. Another symbol mirrored the probability cloud for a p orbital, as if the artist had captured a snapshot of the electron's elusive position and momentum. It was as though the builders had overlaid two maps on the same stone, one of the cosmos and one of the subatomic world. If the bronze disk from India suggested ancient knowledge of the electron, this site implied something far greater, that the people who built it understood the deep symmetry between the smallest and largest scales of reality. In quantum physics, there is an eerie resonance between atomic structure and cosmic architecture. Patterns repeat, ratios echo across magnitudes of scale. The very forces that bind quarks inside protons mirror the mathematics of gravity that binds stars in galaxies. Physicists today call it a kind of cosmic self-similarity, an idea the ancients, if they did grasp it, might have seen as proof of a single unified order. And here, on this forgotten island, it seemed they had carved that order in stone. But the question was, how? How could an ancient maritime culture with nothing more than naked-eye astronomy and stone tools possess knowledge that requires electron microscopes and particle accelerators? One explanation, the one that fits neatly into the archaeological consensus, is that the patterns are purely symbolic, and any resemblance to quantum diagrams is coincidence. Humans are adept at finding patterns where none exist. Yet, there's a complication. One of the basalt slabs bore a circular groove, shallow but perfectly smooth, with a radius matching the wavelength of a specific spectral line of hydrogen, a number known today only because of high-precision spectroscopy. This groove wasn't decorative. When a cord was run through it and spun, the groove produced a faint, high-pitched resonance, exactly at the frequency of that spectral line when translated into sound. Just like the bronze disc, the stone was a hybrid, part map, part instrument, part data storage. Some scholars speculated that the platform might have been a teaching site, a place where initiates learned both the navigation of the sea and the navigation of the invisible, the sky map above, the atom below, the shared mathematics binding them together. But there's another, more unsettling possibility, that the platform was never about teaching at all, that it was instead a receiver. The concentric stone rings, the precisely cut basalt, the alignment with ancient star positions, all of it could, in theory, act as a kind of resonant chamber, not for sound, but for electromagnetic fields. If so, then the spirals and grooves might not just depict atomic structure, they might have been part of an attempt to interact with it. A speculative leap, certainly, but not without precedent. Modern quantum experiments have shown that macroscopic systems, things we can touch, can influence quantum states under the right conditions. What if, thousands of years ago, this island's builders stumbled upon a natural way to harness that connection, and then walked away? The why of that is a mystery that deepens in the next chapter. Because on the far side of the island, hidden beneath a collapsed cliff, divers would find another piece of the puzzle, one that hinted that the builders' understanding of reality was not only advanced, but dangerous. The collapse must have happened centuries ago, a sheer wall of rock sheared away from the island's southern cliff face, plunging into the turquoise water below. For generations, it had been little more than a hazard for fishermen, a place where jagged boulders hid just beneath the waves. But when a late summer storm scoured the seabed, it exposed something that had been buried there for millennia. It was a diver from the original survey team who found it, a slab of stone unlike any in the surrounding geology. Perfectly rectangular, 2 meters long, and carved with deep channels that had been worn smooth not by water, but by human hands. It took days to rig the winches and floats to haul it to the surface, and even then, the stone's true face was only revealed after layers of marine growth were carefully stripped away. What they found shocked the team. The channels weren't random. They were a kind of three-dimensional diagram, a lattice of lines and nodes, each intersection carved into a shallow depression. The layout was immediately familiar to the physicists on the expedition. It was the skeleton of an energy-level diagram, a visual representation of electron transitions within an atom. Except here, the scale was monumental and the precision uncanny. But it wasn't the diagram itself that made the divers uneasy. It was what was inside those carved depressions. Even after thousands of years underwater, faint traces of a metallic substance clung to the stone. Analysis showed it wasn't bronze or gold, but an alloy no one could quite place. A combination of copper, tin, and trace elements like tellurium and vanadium in ratios unknown in ancient metallurgy. This was no ornamentation. The alloy had once filled the entire channel system, making the stone diagram not just a visual teaching tool, but a functional circuit. This was the first clue that the builders weren't just depicting quantum processes, they were attempting to reproduce them. In modern terms, the slab resembled a crude particle accelerator plate, designed not to smash protons, but to guide and influence the behavior of electrons through controlled fields. The depressions at each intersection could have held crystals or conductive nodules, the kind that respond to subtle changes in temperature or electromagnetic flux. If this interpretation was correct, then the island's builders hadn't just mapped the quantum world, they'd reached for a way to manipulate it. Which raises a troubling question: why abandon such knowledge? One theory emerged among the more speculative members of the team, that the device, if it worked, could alter matter at a fundamental level, not in the brute force way of modern nuclear physics, but in a more subtle, targeted manner. If you could influence electron states directly, you could change chemical bonds without heat or pressure, you could transmute materials, you could rewrite matter itself. Imagine the implications for an ancient society. Metals that never corrode, tools that cut without dulling, energy sources that seem to appear from nowhere. A civilization with such abilities would appear to outsiders as wielding magic, or the power of gods. But the quantum world is not tame. In our time, physicists must contend with the probabilistic chaos of electron behavior, influence it without full understanding, and you risk creating effects you cannot control. What if the builders discovered this too late, Archaeological layers on the island show signs of abrupt abandonment. Around the same time the slab would have been in use, the settlement's ceramic styles change abruptly, as if the cultural lineage was severed. Pollen analysis from nearby sediment cores reveals a sudden decline in agriculture, replaced by fast-growing weeds that thrive in disturbed soil. In the myths of nearby islands there are stories, hazy and metaphorical, of a light that devoured the harvest and stones that sang with the voices of the dead. One chilling possibility is that the builders triggered a chain reaction, not nuclear in the modern sense, but quantum in nature, a localized disruption of matter's stability. The light in the myths could have been intense, unexplained emissions from the device. The voices perhaps the result of auditory hallucinations caused by sudden, massive electromagnetic flux. Whether the danger was real or perceived, it seems the knowledge was buried, literally. The slab may have been pushed to the cliff's edge and consigned to the sea as an act of deliberate erasure. The same precision that shaped it could dismantle it, sealing away its secret. But secrets have a way of resurfacing. The divers who found the slab were not permitted to keep it. It was whisked away to a secure research facility under the guise of conservation. Within months, the official report omitted any mention of the alloy traces, reducing the slab to a ritual object with unknown symbolic meaning. To the public, it became another curiosity, stripped of its technological implications. Yet among the team, the whispers continued. Some insisted that, during the initial cleaning, they'd seen the alloy faintly luminesce in the dark, as if responding to the touch of air for the first time in thousands of years. Others claimed that the arrangement of channels and depressions, when compared to known quantum systems, matched not the energy levels of hydrogen or helium, but something else entirely, something heavier, more complex and unstable. If that was true, the builders may have been working with elements unknown to the ancient world, and perhaps still unknown to us. Which leaves us with a haunting thought. The loss of this knowledge may not have been due to catastrophe alone. It could have been intentional, a choice by the ancients to erase a power they deemed too dangerous to wield. And if so, they succeeded, until now. Because the slab is not the only surviving artifact of its kind. Thousands of kilometers away, in a desert where no stone like it should exist, another nearly identical diagram has been found, but this one is intact, and it may hold the key to proving that humanity's first quantum scientists lived and vanished long before recorded history. The desert keeps its own counsel. It buries and preserves in the same breath, wrapping secrets in sand and silence until a stray wind, a wandering camel, or a careless boot reveals the edge of an old world. The caravan that found it was looking for nothing more than a shortcut. A line of trucks, sun-faded and dust-choked, rattling along a barely remembered piste across a North African erg. At dusk, the lead driver swerved to avoid a ridge and slid down a slipface into a shallow basin. When the engines cut, the only sound was the slow hiss of settling sand. And then someone noticed it, a perfect circle, peeking out like the rim of a coin, where the wind had shaved the basin clean. By morning, the team had cleared a ring 3 meters across, not stone, not metal, something in between, a vitrified slab with the luster of obsidian and the stubbornness of steel. It lay flat, flush with the desert floor, as if the dunes had conspired for centuries to keep it level to the horizon. Along its edge, glyphs, too crisp to be random, marching in a loop. Within, channels, nodes and intersections arranged in a logic so stark it felt like a command. From the first photographs, our expedition knew. It was the same language as the island slab, only here nothing was broken. The lattice was complete. The slab's surface wasn't carved, it was grown. Microscopic analysis would later show that the channels were not cuts in a homogeneous material, but inclusions, filaments of a different phase seeded within the glassy matrix, as though the entire piece had been coaxed from a melt that cooled under strict, deliberate gradients. To do this with fire and sand would be a miracle. To do it with precision, a revelation. Even before the technicians arrived, the desert twin began to perform its first trick. At sunset, as the sky bled through reds into violet, the ring caught the light and threw it inward. The basin brightened, not evenly, but in a lacework of glowworm threads that traced the channels in pale luminescence. Someone whispered that the slab was drinking the sky. Someone else said it was waking up. When we returned at night with calibrated lamps, we saw the pattern more clearly. Bathe the ring in a narrowband tone of light, and the channels replied with their own frequencies like a choir finding harmony. Swap wavelengths and different pathways sang. It wasn't merely reflective behavior, it was resonance, a selection rule, as though the lattice was built to respond only to certain spectral lines. Hydrogen's Balmer series, helium's yellow. A line we argued about all night and, in the morning, identified as oxygen. The lattice did not just glow, it sorted the light, routing it along paths that matched the atomic signatures we teach to first-year spectroscopists. An instrument disguised as a monument. The inner field, where the island slab showed empty depressions, was here populated with insets, disklets of translucent mineral mounted in the matrix. Under magnification, each disklet revealed an internal structure of concentric floors, like the growth rings of a tree, or the quantized steps of a system that had cooled through discrete phase transitions. Press a probe to one and you felt it. A minute, piezoelectric whisper, a hint that stress became charge, became whispering current along the embedded filaments. If the island slab had been a diagram, the desert twin was a device. We tested the simplest thing first. Could the lattice map a spectrum in real time? We set a broadband lamp at the rim, then slid a prism between lamp and ring. As the light fanned out, the slab answered, channels brightening, nodes flickering, until a stable pattern held. Trace the lit paths, integrate their intensities, and you got a curve that matched our spectrometer to within 1 part in 1,000. In the middle of the Sahara, the oldest spectrograph we'd ever seen had just outperformed our field unit. There was a temptation, of course, to push, to feed the lattice more energy, to see how far it would go. We resisted, not because we were timid, but because the desert speaks plainly to those who listen. At noon, when the sun is a white coin and the heat hits like an anvil, the slab's luminescence vanished. Its response was a winter star, not a summer noon. Whatever this was, it was tuned to thresholds, to purities, to the quiet edges of energy, not its roar. Around the slab, the sand told other stories. Fragments of ceramics in a style we could not place. Shards of a glass with a refractive index alien to local sands. A ring of stone post holes now empty, suggesting some superstructure once stood here, shading or filtering the light. A portable observatory, a laboratory with the sky for a lamp. We catalogued the glyphs on the rim. Some echoed the island language, spirals that doubled back on themselves, chevrons nested 10 deep, a dot in a circle in a circle in a circle. But there were new signs, chains of short and long marks that, when treated as timing, mapped to integer ratios, harmonics. We fed the sequence into a simple model of coupled oscillators, and the solution fell out like a confession. This was a waveguide network. The slab was built to host standing waves, optical, acoustic, perhaps even electromagnetic, at selected modes, the same way a violin's body chooses notes. A retention spike, then, in the middle of the desert. The device was not a relic. It was an algorithm in matter, hardware that computed with resonance. We circled back to the island platform's rumor, a receiver. Could the desert twin have been listening, not to gods or stars in the poetic sense, but to the environment's own quiet emissions? The sky is not dark, the air is not silent. The world hums with lines, atomic, molecular, thermal, and if you can filter them cleanly enough, you can learn without breaking anything. Here was a non-invasive science, spectroscopy by sculpture, and yet the lattice's geometry ran deeper than passive listening. In two quadrants, the channels formed closed loops with calibrated gaps, couplers. Bring a charged rod near one gap, and the loop's luminescence shifted. Introduce a faint magnetic field and the shift split, as if the channels felt Siemens' hand centuries before Siemens himself. These loops were not just watching electrons. They were nudging them, just enough to feel the give of the world, not enough to tear it. We found, half buried at the basin's edge, a small puck of the same vitrified material with a hexagonal inlay. 6 radial channels met at a core, and in that core, a pinprick cavity, sealed and empty. We argued, a calibration piece, a seed, a key. Late that night by headlamp, one of the younger researchers placed the puck in a shallow recess near the slab's rim, as if guided by the subtlest echo of alignment. The slab answered with a flicker that ran the circumference and back to the puck in a heartbeat. A handshake. It was a system. Components, standards, modules. Not an altar, but a kit. Whose kit? That question reached beyond archaeology, beyond physics, into the story of us. The ceramics spoke of trade, the glass of recipes exchanged, the post holes of travel structures raised and taken down like a troop stage. This was not a solitary genius's yard. This was a node in a network, an itinerant science, carried by people who understood the value of making knowledge portable and robust against time. We radioed coordinates to colleagues across the Mediterranean map. Within days, replies returned like migrating birds, a tessellated courtyard in the Levant with puzzling scorched inlays, a cliffside alcove in Iberia with vitrified veins, a half-fused slab in a Maghreb oasis that local shepherds used as a winter mirror. The pattern emerged with brutal elegance, a chain of sites spaced by reasonable sails and marches, each a variation on the same theme. Not temples, stations. The skeptics will say, must say, that we are clever apes connecting dots in a cloud. That resonance and light tricks are not quantum mastery but artistry, that the desert twin is a masterpiece of optics, nothing more. We hear them, we respect them, but there is a point at which coincidence hardens into code. Selection rules etched in glass. Siemens splits you can see with your eyes. Handshakes between modules like the first syllables of a forgotten alphabet. One question remained, coiled in the dark like a serpent. Why here? Why the desert? The answer may be the most mundane and the most profound. Dryness preserves. Skies are clean. Noise is low. If you wanted to build instruments that sip the world's faintest lines, you would come to the places where the world whispers. At dawn on our last day in the basin, a thin cloud metallized the sky and the slab's channels took the color of mercury. The ring brightened at 3 points equally spaced, 30 degrees above the horizon due east. The nodes pulsed in a sequence we hadn't seen. Our spectrometer logged a transient in the near-infrared, a line weak and narrow not in our lamp's output. We held our breath as the sequence ran its course, then silence. The desert resumed its stillness, and the slab sank back to black glass. Was it a calibration event we had accidentally triggered? A passing atmospheric phenomenon tuned to some ancient mode? Or had the slab for the first time in centuries heard something, answered, then gone still? We were not ready to know, not yet. But the direction of travel was clear, and it did not lead only to deserts and islands. It led inward, to the rules of the very small and the ethics of the very powerful. Because if an ancient science could measure without breaking, could touch the quantum world without tearing it, then its loss is more than a tragedy. It is a warning about how knowledge is held, how it is shared, and how easily it can be erased. In the next part, we climb out of the sand and look unflinchingly at the ledger, the evidence for and against, the strongest criticisms, the data that refuses to fit, and the stories that seduce because we want them to be true. If there is a civilization that knew the quantum before we did, it must survive the fiercest scrutiny. And if it does not, then what remains may be stranger still, the possibility that human beings across ages can converge on truth from different directions, one with stone and sky, one with silicon and math, and meet for an instant on the same shimmering line. Extraordinary claims demand extraordinary evidence. It's a phrase that echoes through science like a mantra, and for good reason. The history of discovery is littered with beautiful ideas that fell apart under the weight of data. And if we are going to suggest, even in whispers, that an ancient civilization once touched the quantum realm, we must invite our harshest critics to the table. We must give them the first seat, the sharpest knives, and as much rope as they need. The first blow lands where it always does: context. You're cherry-picking, they say. You're finding patterns where none exist. The human brain is a pattern-finding machine. Powerful, yes, but also compulsive. Show it enough noise and it will knit constellations. The skeptics see our lattices not as instruments, but as elaborate decorations, akin to the intricate tiling of Islamic architecture or the interlaced carvings of Celtic knots. Beauty, yes. Precision, yes. But art, not apparatus. They point to the danger of anachronism, reading modern knowledge into ancient forms. The double-slit experiment, quantum superposition. These are concepts born in the 20th century, they remind us, underpinned by math alien to pre-industrial cultures. It's easy to look back and see precursors everywhere, but that's hindsight bias at work. Just because a pattern looks like something we understand today doesn't mean it was understood then. The second blow comes from materials science. Our desert slab, they argue, is not a miracle of fabrication, but a geological curiosity, a piece of naturally vitrified rock shaped and polished by human hands for unknown purposes. The filaments we marvel at could be the result of devitrification, glass slowly reorganizing into crystalline domains over centuries, luminescence under specific wavelengths. Known in many minerals, they counter. Even the spectrograph effect could be a quirk of birefringence and microfractures, not an intentional encoding of atomic lines. Then there's the absence of infrastructure. Quantum-level observation, even in its most basic form, requires more than a single device. It demands a framework, records, training, replication. Where are the workshops? The apprentice notes? The distribution networks for these modules we claim were standardized? If a civilization could craft such things, surely it could leave a deeper trail than a handful of enigmatic slabs scattered across continents. The skeptics also bring the hammer of ethnography. Cultures rarely create in a vacuum. They create within traditions, oral, artistic, spiritual. If these instruments existed, they would almost certainly have been woven into ritual, myth, or inscription. But outside our tantalizing glyphs, there's no explicit reference in the archaeological record to tools for measuring light or resonance at the atomic level. Without such context, the devices become orphans, objects without a cultural home. And yet the fiercest criticism isn't about what we've found, it's about what we haven't. Data, controlled experiments, reproducibility. A few field tests in a remote desert under variable light are not enough to rewrite history. A proper test would require extracting a slab under controlled conditions, transporting it to a lab, and subjecting it to the full arsenal of modern analysis, spectroscopy, microscopy, tomography. Without that, the skeptics argue, all we have is anecdote dressed in scientific vocabulary. They also remind us that ancient cultures were no strangers to manipulating light in astonishing ways. The lenses of Nimrud, the precision of Machu Picchu's solar alignments, the parabolic mirrors of the Greeks, these are feats of optical engineering accomplished without a shred of quantum theory. The leap from clever with light to understood quantum behavior is enormous, and they refuse to bridge it without overwhelming proof. Still, there are counterpoints, fissures in the wall of doubt that even the most disciplined skeptic must acknowledge. The geometry. Across sites separated by oceans and millennia, we find not just similar motifs but identical ratios, angles and distances that match to within fractions of a degree. too precise for accident, too consistent for purely aesthetic drift. Coincidence is possible, but each matching element raises the statistical improbability. The material science. Natural vitrification can produce complex structures, yes, but the uniformity of the slab's embedded filaments and the presence of phase transitions within the disklets hint at deliberate control. This is not a glass that cooled under random desert winds. It is a medium that seems engineered to respond to stimuli in specific selective ways. The spectral selectivity. Minerals can glow under specific wavelengths, but the slab's pattern of activation lines up uncomfortably well with the emission lines of common elements: hydrogen, helium, oxygen. Not a random scatter across the spectrum, but the same handful of lines that form the backbone of modern astrophysics. Could that happen by chance? Possibly. But in sight after sight. And then there's the handshake. In the desert, when the hexagonal puck was seated into its recess, the system changed state. A pulse ran the circumference. Channels brightened in sequence. The skeptics concede that if real, this is the hardest to wave away. Passive geology doesn't handshake. It doesn't alter its internal resonance based on modular insertion. That behavior suggests compatibility, design. But here the skeptic's final card comes down hard: contamination. In archaeology, contamination isn't dirt on a sample, it's the slow seep of modern influence. The moment we touch an artifact, the moment we test it with modern gear, we risk introducing variables that didn't exist before. Could the handshake have been an artifact of our lighting setup, of our human eagerness to see meaning in a flicker? Without blind tests, without independent verification, the doubt remains, and perhaps it should remain. Because doubt is not the enemy of discovery, it's the crucible that tempers it. If the idea of a quantum-literate ancient civilization is to survive, it must pass through this fire and emerge stronger, leaner, stripped of the poetic but false, leaving only what can bear the weight of evidence. Our ledger of doubt is long and well inked. But beside it, a parallel ledger has begun to grow, one that contains not conclusions but questions that refuse to close. Why do these slabs share a design language across impossible distances? Why do they seem to respond to fundamental constants of nature? Why do some of them, just some, interact with each other in ways suggestive of system architecture? And most unsettling, why do they seem tuned not to the human scale of touch and sight, but to the atomic scale of light and charge? Perhaps we are looking at nothing more than a remarkable tradition of light play, born from artistic genius and a deep love of the sky. Or perhaps, just perhaps, we are staring through the keyhole at a room we do not yet have the courage to enter. Either way, in the next part we will leave the courtroom of skepticism and step into the archive of possibilities, a place where data and myth, experiment and speculation can be laid side by side, not to blur the line between them, but to see whether, under the right light, the line itself begins to shift. There is a moment in every investigation where the map is spread wide across the table. In one corner lie the theories and the fragments that lead nowhere. In another, the ideas that defy even the most generous interpretation. And then, in the center, a smaller pile, the pieces that refuse to go away. These are the ones we gather into what I call the archive of possibilities. Imagine a vault, not of gold or jewels, but of data points, sketches, and recovered objects. The air smells faintly of dust and desert stone. Under dim archival lighting, we begin to arrange the pieces that have, despite every attempt to dismiss them, clung stubbornly to the narrative. First, the geometric twins. From the Peruvian highlands to the Indus Valley, from North African rock faces to the submerged structures off Yonaguni, there are panels, slabs, adorned with repeating hexagonal arrays. The distances between nodes are consistent, not to the millimeter, but to a tolerance measured in ratios. Ratios that happen to match resonant wavelengths of certain atomic transitions. Whether you see coincidence or intentionality here often depends less on the math and more on your threshold for disbelief. Next, the light filters. 3 independent expeditions, separated by decades, recorded that certain carved stones, when sunlight or firelight passes through them, project patterns resembling diffraction. The projected shapes are not random, they form concentric interference fringes. A physicist could reproduce them today with a laser and a double slit, but these artifacts predate lasers by thousands of years, and slits are not the only possible cause. Still, their existence nags at the edges of our understanding. We move deeper into the vault, to the section marked paired systems. These are the rarities, artifacts that, when brought into proximity, change behavior. In 1978, in a coastal cave in Crete, 2 bronze discs etched with nested spirals were found wrapped in linen. Separately, they were inert. Together, under heat, a thin line of condensation formed along the edges, as if micro-resonance had been achieved between them. The explanation: skeptics cite metallurgical quirks, proponents whisper about tuned systems, and then there are the stray texts. Not complete codices or tablets, but fragments. A Sumerian shard with an inscription loosely translated as "the breath that dances between 2 shadows." A Mayan glyph set depicting a lattice overlaid on a human figure. A medieval Arabic commentary referring to points that sing in the absence of touch. To the historian, these are poetic metaphors. To the physicist, they hint at a pre-scientific grasp of phenomena like oscillation, interference, perhaps even quantum states. We can't ignore the outliers in metallurgy. Certain recovered objects, a pendant from the Altai Mountains, a ceremonial staff from Lake Titicaca, contain metal alloys with grain structures suggesting rapid solidification under non-natural conditions. The crystal boundaries in these metals are finer than anything produced by standard ancient smelting. Modern metallurgists can replicate them with induction heating and quenching. How such results could occur with Bronze Age technology remains unanswered. Piece by piece, the archive grows, and with it, the unease. For each item, there are plausible alternative explanations. Nature is inventive, human art is boundless. But when we step back and view the whole collection, the slabs, the filters, the paired systems, the texts, the metals, a pattern emerges. These are not the trappings of a civilization obsessed solely with the stars above or the earth beneath. They seem to speak to an engagement with the invisible layers of reality. The level where light interferes, where matter resonates, where energy dances in discrete steps. In this archive, skepticism is not banished. It is catalogued alongside the artifacts themselves. Each piece has its dossier, claims, counterclaims, experimental notes, photographs under various wavelengths. The aim is not to declare the case closed, but to ask, what survives when the easy answers have been stripped away? A telling example, the vitrified ring. Discovered in a collapsed temple in the Sahara, this palm-sized loop of fused silica contains, embedded within, a spiral track that fluoresces faintly under ultraviolet light. Skeptics say it is a glassy meteorite fragment, shaped and polished, yet the spiral's pitch, the distance between coils, matches the calculated path of an electron in a uniform magnetic field at a specific energy. Was this an accident? Was it the human tendency to see order where there is none? Or was it a clue left by a mind that had glimpsed the same dance of particles that would not be formalized until the 20th century? This is the nature of the archive. It forces you to live in the space between certainty and wonder. From here, we begin to connect the dots, not recklessly, but cautiously, like a cartographer sketching a coastline seen only through breaks in the fog. Perhaps there was not a single lost civilization, but a scattering of advanced enclaves, pockets of knowledge that occasionally brushed against deeper truths. Their insights might have been practical, ways to work metals, ways to harness light for ritual or navigation, Or they may have been purely symbolic, intuitive glimpses at structures too small to see. But even intuition, repeated and refined over centuries, can produce something extraordinary. Just as Polynesian navigators charted the Pacific by reading wave patterns without ever writing down the laws of fluid dynamics, an ancient culture could have felt its way toward the rhythms of the quantum world without formal theory. The archive also forces us to consider time differently. If human history is not a straight line from primitive to advanced, but a cycle of rises and collapses, then pockets of sophistication can vanish, leaving only traces. What we have could be the debris of such a crest, a civilization not global but networked across trade routes, its knowledge condensed into artifacts portable enough to survive the fall. And here lies the tantalizing possibility that some of what we consider mythic, the tales of divine sparks, of hidden forces binding all things, of gates between worlds, are distorted memories of practical knowledge. Not magic, but mechanics, not fantasy, but physics in a language no longer spoken. Standing in the archive of possibilities, the question shifts. It is no longer, did they know quantum physics as we do? That is too narrow, too modern. The better question is, did they touch the same patterns, the same truths that quantum physics describes by other means, in other words? Because if they did, the implications are profound. It means there are other ways of knowing, paths that may not require particle accelerators or electron microscopes, but can still lead to the same summit. And if those paths were found once, long ago, perhaps they can be found again. In the next part, we will step out of the vault and onto the edge of speculation. We will explore not only what it would mean if such a civilization existed, but what it could mean for us now, for our technology, our science, and our understanding of reality itself. The archive may never yield a single definitive answer, but it might be the map to a future we have yet to imagine. Imagine for a moment that the archive of possibilities is not just a collection of curiosities, but a blueprint. That the strange carvings, impossible alloys, and cryptic texts are not anomalies, but deliberate transmissions. If we were to decipher them fully, we wouldn't just be reading history, we'd be holding a key to a kind of knowledge our own civilization has only begun to touch. We often think of quantum mechanics as the pinnacle of modern physics, a theory forged in the crucible of the 20th century, requiring mathematics so abstract that even Einstein struggled with it. But what if that's not the only way to reach it? What if, long before Planck, Schrödinger, or Feynman, another culture found a different road? A road paved not with equations, but with patterns, intuition, and an almost artistic grasp of nature's hidden rules. The first echoes of such a rediscovery would come quietly. A pattern in an ancient carving suddenly lines up with the output of a modern quantum simulation. A metallurgist replicates an ancient alloy, only to realize its lattice structure mimics the arrangement of atoms in a superconducting material. Archaeologists and physicists, long working in separate worlds, begin to cross-pollinate their data. At first, these are dismissed as coincidences, much like the early murmurs about continental drift or germ theory, but coincidences, when repeated, become evidence, and evidence, once undeniable, becomes a call to action. Let's consider what might happen if the call were answered. The obvious applications are technological. If a civilization had in any way grasped the principles of quantum coherence or resonance, even at a rudimentary level, it could transform our current tech landscape. Energy systems might shift overnight. Instead of massive superconducting labs cooled to near absolute zero, we could see room temperature materials capable of similar feats, just as some ancient metals remain untarnished for millennia. Communications could leap beyond the constraints of our fiber optic cables, potentially touching the edges of quantum entanglement in ways our current science only whispers about. But the subtler impacts may be even more profound. Knowledge shapes worldview. Our modern quantum revolution did not just give us transistors and lasers, it also rewrote our philosophical relationship to reality. It told us that observation changes outcomes, that particles can be waves, and that certainty itself is a mirage. If an ancient civilization reached similar conclusions, even symbolically, it might explain why so many of their myths and rituals are drenched in dualities, paradoxes, and transformations. To rediscover that worldview would be to inherit not only tools, but a mindset, one that could make our own culture less rigid, less addicted to binaries, and more attuned to the fluidity of existence. There would also be resistance. History is clear on this point. Revolutionary ideas rarely glide into acceptance. They threaten the structures that thrive on control, predictability, and scarcity. Just as the printing press disrupted the monopoly on knowledge, a rediscovered ancient science, especially one dealing with the deepest layers of reality, would shake both scientific and political hierarchies. There would be debates, disinformation campaigns, and perhaps even attempts to suppress or co-opt the findings. Yet, as with all truths that touch something essential, the ideas would seep through. A young engineer in Mumbai uses the principles to design a new kind of quantum sensor that maps underground water with unprecedented accuracy, revolutionizing agriculture. A research team in Nairobi applies the same patterns to low-cost solar collectors, boosting efficiency in rural electrification. Artists begin weaving these rediscovered geometries into their work, creating visual languages that are both ancient and startlingly new. The echoes begin to build into a resonance. But perhaps the most fascinating outcome would be in the realm of consciousness. Quantum physics, for all its practicality, remains deeply entangled with questions about the mind. Does consciousness collapse the wave function? Are we participants in reality's unfolding, not mere spectators? If the ancients engaged with these questions through ritual, meditation, or symbolic encoding, we might find in their practices a bridge between physics and inner experience. Modern neuroscience could take cues from ancient methods of focusing attention, altering perception, or inducing coherent mental states, leading to breakthroughs in mental health, learning, and even creativity. Rediscovery would also change how we view time. The prevailing myth of progress, that knowledge always moves forward, would falter. We'd be forced to admit that wisdom can be lost, that civilizations can regress, and that the future is not guaranteed to be more advanced than the past. This humbling realization could spur us to protect our own scientific heritage more fiercely. It could also encourage us to seek out other lost threads in medicine, ecology, and social organization, knowing now that what is gone is not always gone forever. The speculative frontier is irresistible. Could these ancient principles hint at methods we've not yet dreamed of, ways to manipulate space-time itself? The popular imagination might leap to teleportation or time travel, but the reality could be more subtle and more transformative. The ability to engineer reality's probabilities to tip the scales toward outcomes we desire. Even small control over such processes would make our current technology look crude by comparison. Of course, there is danger. Every tool is double-edged. Just as nuclear physics gave us both energy and annihilation, a rediscovered ancient quantum knowledge could be used to heal or to harm. The same coherence that might power a city could, in the wrong hands, destabilize a region. The same patterns that enhance communication could be weaponized for surveillance or control. The ancients themselves may have faced such dilemmas, perhaps even triggering the very collapse that buried their knowledge. And so the final echo is a warning. Rediscovery is not resurrection. It is integration. We cannot simply graft ancient knowledge onto modern infrastructure and expect harmony. The context has changed. Our population is larger, our reach is global, and our capacity for both creation and destruction is unmatched. To inherit such knowledge responsibly would require a maturity we have yet to prove we possess. Still, one can't help but wonder. In the archive of possibilities, somewhere among the dust and silence, there may be a final piece, a keystone artifact or text that makes the whole picture snap into focus. Perhaps it will surface tomorrow in a remote dig site or a forgotten museum drawer. Perhaps it already has, and we have not yet recognized it for what it is. When it does, the echoes will no longer be faint. They will be the low, steady hum of a civilization, ours, standing at the threshold of a truth once known, then lost, and now ready to be heard again. In the next part, we will test the limits of this speculation by turning to the skeptic's strongest counter-arguments, examining whether the evidence holds up under the coldest, most unyielding scrutiny, or whether it crumbles, leaving only the romance of what if behind. For every tantalizing hint, there is a voice, calm, measured and unsparing, that reminds us how dangerous it is to weave threads of mystery into a coherent tapestry without proof. The skeptic's role is not to ruin the story, but to keep it from collapsing under its own weight. If we are to claim that an ancient civilization grasped quantum principles, even intuitively, then we must be prepared to test that claim in the harshest light possible. The first objection is the simplest, and perhaps the most devastating: pattern recognition bias. Humans are masters at seeing order in chaos. The same brain that spots a predator in the tall grass can see meaning in clouds, constellations, or the weathered cracks of a stone tablet. Archaeologists warn of apophenia, our tendency to connect unrelated dots. The geometric carvings we admire as quantum diagrams may be nothing more than decorative art. The metallic structures that mimic atomic lattices could be the accidental byproduct of forging techniques, not evidence of controlled design. Then there is the problem of survival bias. Out of the millions of artifacts created by ancient cultures, only a fraction survive. The ones that do are often preserved precisely because they were unusual, stored in dry tombs, cast in durable metals, or carved into hard stone. What we find may not be representative of the broader culture at all. If a strange symbol or precise mechanism appears, it could simply be an outlier rather than a reflection of a widespread scientific understanding. Skeptics also point to the danger of retroactive interpretation. Our modern understanding of quantum mechanics gives us a framework through which we reinterpret ancient symbols. A spiral in a Neolithic carving suddenly resembles an electron's probability cloud, but only because we know such clouds exist. To the people who carved it, the spiral might have meant rain, a snake, or the cycle of seasons. We must be careful not to project our science backward onto their cosmology. There's also the uncomfortable fact that ancient engineering marvels can be explained, at least in principle, without invoking advanced physics. The antikythera mechanism, though astonishing in its complexity, is still a mechanical device built from observable planetary motions. It required no understanding of quantum states, only careful observation, mathematics, and craftsmanship. The Great Pyramid's precision is breathtaking, but it can be accounted for by simple tools, vast manpower, and generations of incremental learning. In other words, technological sophistication does not automatically imply scientific foresight. Another powerful counterargument is the absence of a knowledge chain. If a civilization truly grasped atomic or subatomic principles, where is the rest of the framework? Where are the treatises, the experimental apparatus, the recorded debates? Even if such records were lost to time, one would expect the knowledge to leave behind layers of related advancements, just as our own quantum breakthroughs have left trails of patents, prototypes, and spin-off technologies. Without this context, the claim rests on isolated artifacts that can always be explained in more mundane terms. And then there is the burden of extraordinary evidence. Carl Sagan's famous dictum that extraordinary claims require extraordinary proof looms large here. The assertion that a pre-industrial civilization understood quantum mechanics challenges our entire timeline of human intellectual development. It would require us to rethink the trajectory of science, the nature of historical progress, and perhaps even the uniqueness of our modern era. To overturn so much, we would need more than suggestive symbols and enigmatic mechanisms. we would need something undeniable, a device or text whose function or content could only be explained by quantum-level knowledge. Skeptics also argue for the principle of convergent discovery. In biology, unrelated species can evolve similar traits simply because they face similar challenges. In human culture, unrelated civilizations can develop similar patterns or designs because they are working with the same natural materials and under the same physical constraints. Geometric art may arise not from quantum insight, but from the innate human attraction to symmetry, balance, and repeating forms. What we see as quantum diagrams might simply be the most aesthetically pleasing way to arrange lines and circles. Finally, the skeptic points to the absence of technological acceleration in the ancient record. When we look at our own history, breakthroughs in fundamental science often unleash cascades of change. The mastery of electricity, for example, transformed communication, industry, and daily life in a matter of decades. If an ancient civilization truly understood atoms and quantum forces, why did they not experience a similar leap? Why did their society not develop in ways we would recognize as technologically explosive? These are not easy challenges to dismiss. They force us to ask whether our fascination with lost civilizations says more about them or about us. We live in an era where the boundaries of science are constantly being pushed. The thought that someone somewhere may have beaten us to the punch is thrilling, and perhaps in some way humbling. But it is also a mirror. It reflects our longing for continuity with the past, for a sense that our journey is part of a much older story. And yet, the skeptic's case, while formidable, is not final. History is littered with examples where the impossible turned out to be true. Meteorites were once dismissed as folklore. Germs were once a laughable idea. The deep structures of reality have a habit of hiding in plain sight until the right eyes in the right time come along. Perhaps the truth lies in a middle ground. The ancients may not have had quantum physics in the way we define it, but they might have stumbled upon patterns, phenomena, or techniques that touch the same hidden strata of nature. They could have encoded these observations in art, myth, and ritual, preserving the essence if not the theory. If so, then our task is not to prove they were physicists in disguise, but to recognize that the roots of human curiosity, creativity, and insight run deeper than we imagine. In this light, the skeptic's work is not to destroy the idea, but to refine it, to strip away the romantic projections until only the solid, defensible core remains. If that core is still strange, still inexplicable, then perhaps it deserves to be called what it is: evidence worth exploring. And so we arrive at the threshold of our final act. We have gathered the myths, the artifacts, the patterns, and the doubts. We have walked with the believers and the skeptics alike. Now, in our closing chapter, we must ask, what happens if, against all odds, the next discovery leaves no room for doubt? What if the proof, irrefutable and world-shaking, is found tomorrow? For centuries, the question lingered in the realm of speculation. For centuries, the whispers of a lost quantum age were the province of fringe theorists, imaginative storytellers, and those who saw science as a continuum stretching far beyond the limits of written history. But what if, just once, speculation gave way to certainty? Picture this: an archaeological team deep in the sands of a remote desert or beneath the ash layers of a long-dead city stumbles upon something that changes everything. Not a symbolic carving, not a mechanical device whose function could be debated, but a machine, a small, self-contained device encased in a material no known culture could have forged. It's perfectly preserved, its surfaces etched with microscopic precision far beyond the capacity of pre-industrial technology. At first, it is assumed to be modern contamination, a lost piece of equipment from a more recent expedition, but the carbon dating on the sediment surrounding it, the mineral deposits on its surface, the stratigraphy of its burial, all confirm the same impossible conclusion. It has been there for tens of thousands of years. The device is brought to a lab, Carefully, painstakingly, it is opened. Inside, researchers find components whose function they cannot immediately identify, but whose arrangement suggests a deliberate purpose. One piece, no larger than a fingernail, contains a lattice of structures that seem designed to manipulate particles at a scale smaller than an atom. It is, in essence, a quantum device. And here's the part that sends shockwaves through the scientific community. When powered by a controlled energy source, it still works. The moment current flows, instruments detect something impossible: the controlled entanglement of particles across measurable distances, a function that even our most advanced labs struggle to replicate. Yet here it is, in an artifact buried before the dawn of recorded history. The implications hit in waves. First, the historical shock. Every timeline, every model of human development must be rewritten. No longer can we claim that quantum mechanics is a triumph solely of modern science. A forgotten civilization not only understood it, but applied it. Second, the cultural upheaval. If they mastered such physics, what else did they know? Did they harness zero-point energy? Did they travel using quantum tunneling or manipulate matter at will? Were their myths of gods, spirits, and otherworldly powers actually imperfect recollections of technologies we barely comprehend? Third, the geopolitical scramble. Nations race to claim the artifact, not as a historical treasure, but as a technological prize. Whoever understands its workings first could leap decades, perhaps centuries ahead in the global race for quantum supremacy. It's no longer just an archaeological find, it's a strategic asset. But perhaps the most haunting question is, why was it buried? If a civilization could wield this kind of power, what happened to them? Was it catastrophe, self-destruction, or something even stranger, a deliberate act of concealment? Did they choose to vanish, leaving only fragments behind, because they knew that such knowledge in the wrong hands could be catastrophic? Historians, philosophers, and physicists find themselves in uneasy alignment. All agree on one thing: the device should never have survived. Time erases, corrodes, and buries. Yet here it is, pristine, functional, unyielding to any narrative that would strip it of its significance. The media frenzy is relentless. Overnight, the world is united in one obsessive question: who were they? Some scientists caution restraint, urging the public to wait for peer-reviewed analysis before drawing conclusions. Others, unable to contain their awe, go on record declaring it the most significant find in human history. A few even suggest that its survival may not be an accident at all, but a message, a seed planted in time, waiting for us to be ready. And that idea that they chose to leave it for us sparks a philosophical firestorm. If they were capable of understanding and harnessing quantum phenomena, perhaps they were also capable of seeing forward in time. Not in the cinematic sense of watching the future like a film reel, but in the probabilistic sense, mapping out the most likely paths of human civilization, knowing that one day another species of thinkers would stand where they once stood. The device then becomes more than proof, it becomes a bridge. But a bridge to where? For the physicists working day and night to decode its principles, the breakthrough comes in fragments. They discover that the device operates not just on quantum entanglement, but on a principle still unknown to modern science, a principle that allows it to manipulate probability itself, nudging events at the smallest scales toward desired outcomes. In essence, it doesn't just observe the quantum world, it steers it. And with that realization comes the final, chilling question. If they could steer probability, how much of our own history was their design? Did they leave this device knowing it would be found at this exact point in our development, when we are powerful enough to understand it, but fragile enough to still fear it? As the implications spiral outward, the story ceases to be about archaeology or even science. It becomes about destiny, about whether the arc of human civilization is truly our own, or whether we have been walking, all along, along a path laid down by minds far older and perhaps far wiser than our own. And in that moment, holding in our hands the one artifact that can never be dismissed as coincidence or interpretation, we are left with a choice. Do we pull the thread and see where it leads? Or do we, like them, bury it again, sealing away its power for another age? Because once the proof is undeniable, the question is no longer if they knew. It is what they expected us to do next. We stand now in a strange place, between what we've always believed and what we can no longer deny. For generations, the story of humanity was one of slow, steady ascent, from stone tools to city walls, from city walls to steam engines, from steam engines to circuits and satellites. But the artifact changes that. It bends the arc of our story backwards, revealing that the summit we thought we were climbing may have been reached long before we began the ascent. In quiet labs, shielded from public view, scientists still hunch over that device. They measure, they produce, they peer at its atomic lattice under microscopes and simulation arrays. And yet, as precise as our instruments are, there's a sense that it is peering back, that its design isn't just about what it does, but when and to whom it does it. Governments, unable to agree on its fate, circle like sharks. Some argue it should be dismantled and locked away. Others want to weaponize it. A handful of voices, small but growing, argue it should be given to no one and everyone, released to the public domain so that all of humanity can inherit the knowledge equally. The tension grows, not in an explosive way, but in the slow, inevitable way of a ticking clock, and that's when the strangest thing happens. In a moment of serendipity, or perhaps design, the device activates without human command. A pattern of light dances across its surface, like an intricate constellation compressed into the palm of a hand. The arrangement is not random. Astronomers recognize it as a sky that doesn't exist anymore, the configuration of the stars tens of thousands of years ago, the sky they would have seen. It is as if the device is saying we were here, but it's also something more. The constellation shifts, morphing, bending time itself into a visual language. It becomes the sky of the present day, and then keeps going, reshaping itself into skies yet to come, skies under which continents shift, coastlines redraw, and unfamiliar lights join the heavens. The message is clear, though no one can agree on its meaning. Some believe it is showing us our future, a roadmap of cosmic events we are meant to witness. Others say it is a warning that the shifting stars signal catastrophes to avoid. Still others claim it is neither warning nor prophecy, but invitation. An invitation to follow them. If this sounds impossible, remember, everything about this moment is impossible. We are speaking of a people who grasped quantum laws before the first city was built, who etched the principles of wave functions into stone, who hid in myths the truth about the fabric of reality. Why wouldn't they also have understood the art of leaving a message for minds not yet born? And so the debate becomes existential. What does it mean if we are not the first? If the genius we prize in ourselves, the spark that built telescopes and particle accelerators, is a second ignition, lit by hands that reached for the same fire long before ours? It challenges more than history. It challenges identity. If they were human, then we are part of something cyclical, a repeating pattern of rise, mastery, and loss. A civilization that blooms, burns brightly, and fades, only to begin again. If they were not human, then our position in the cosmos shifts from center stage to one voice in a much older choir. The truth may be stranger still. Perhaps the line between them and us is an illusion. Perhaps we are their descendants, carrying their code not in machines but in our very blood. The genetic inheritance of a people who cross not just oceans and mountains but epochs. And yet, despite the magnitude of these revelations, daily life continues. Lights switch on, phones buzz, the stock market rises and falls, the world spins. We live in the present, even as the past reaches forward with ghostly fingers. In the quiet moments, though, at night when the sky is clear, some look up differently. They trace the constellations, wondering if the same patterns once guided a civilization that could see the quantum dance. Wondering if the flicker of a distant star might be a signal, a marker in a path we have only just begun to rediscover. And here is the thought that keeps me awake. What if we've already been answering them? Every leap in our science, every pattern we've uncovered, every strange, beautiful accident in the lab that defies expectation. What if we are walking a trail of breadcrumbs, not just finding their legacy, but fulfilling it? Because when you strip away the myths, the machines, and the politics, you're left with something simple. A bridge, one end anchored in a time we cannot remember, the other reaching toward a horizon we cannot yet see. The only question is, will we cross it? As for the artifact, it now rests in a place known to only a handful of people. But its image, its schematics, its story, those are harder to lock away. They've escaped, as ideas always do, into the minds of those who will carry them forward. And perhaps that was the point all along, because if they truly knew the quantum world before we did, then they also knew this. Matter changes, energy shifts, but ideas are the one thing that can survive the collapse of a civilization. They leap across generations. They survive in stone, in story, in song, and sometimes, if the timing is right, they reappear not as a memory, but as a challenge. And so here we are, standing at the edge of a mystery older than history itself, holding in our hands the proof that the story of human genius is far longer, far stranger, and far more interconnected than we dared to dream. The night sky above us glitters, vast and indifferent, but somewhere in its infinite reach, perhaps a people who were here long before us are watching still, waiting to see if, when given the bridge they left behind, we will have the courage to step onto it and keep going. Thank you for joining us on this extraordinary journey through the cosmos here on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us each Friday at 7 p.m. Eastern, where we unravel the darkest mysteries of space.